Hi, this is Alex from devstories.eu. LlamaIndex Context-Augmented LLM Applications, Episode 9 of 14. If you let autonomous agents pass control peer-to-peer, you easily end up with endless loops or dropped context. Sometimes you cannot rely on agents handing off to each other. You need a central manager in charge of the whole operation. That is the orchestrator agent pattern. In a multi-agent system, letting agents talk directly to each other sounds powerful, but it quickly becomes a debugging nightmare. You lose track of who is in charge, and managing the overall state of the application becomes incredibly complex. The orchestrator pattern solves this by strictly enforcing a hub-and-spoke model. There is one top-level orchestrator agent, and all other agents are treated strictly as tools for that orchestrator to use. Let us walk through a scenario where your system needs to generate a heavily researched technical briefing. You set up an orchestrator agent to act as a strict manager. This manager owns the global state. It remembers the original user prompt, holds the master context, and tracks what has been accomplished so far. It does not do the actual hard work itself. Instead, you provide it with tools. These tools are not simple API wrappers or basic calculators. They are entirely separate, fully functional sub-agents. You might build one sub-agent dedicated to research, equipped with vector search and web scraping capabilities. You might build a second sub-agent dedicated to writing, equipped with stylistic guidelines and formatting logic. In LlamaIndex, you take these subagents and expose their run methods as tools. By doing this, you are wrapping their entire internal reasoning loops behind a standard tool interface with a name and a description. To the orchestrator, these subagents look exactly like standard Python functions. When the user asks for the briefing, the orchestrator evaluates the overall goal based on the tool descriptions you provided. It decides to call the research tool first and passes in the necessary parameters. Control shifts temporarily to the research subagent. It runs its own autonomous loop. It might make 3 or 4 internal tool calls to gather data, synthesize the facts, and formulate an answer. Once the research agent finishes, it collapses all that work into a final text string and returns it. Here is the key insight. The orchestrator never actually yields control of the main process. It just waits for the tool to return a value. The orchestrator receives the research summary, adds it to its own context, and evaluates the next step. It realizes the information needs to be drafted into a document, so it calls the writing tool, passing the fresh research as the input parameter. The writing subagent takes over, does its own internal processing, and hands back the finished text. The orchestrator sees that the final goal is met and delivers the response to the user. This strict separation of concerns makes your system highly predictable. The research agent doesn't need to know the writing agent exists. Neither subagent has to worry about handing off context, formatting the final user response, or deciding when the overall job is done. The orchestrator centralizes all the high-level decision-making logic. By forcing subagents to operate purely as isolated tools within a central manager's loop, you can build massively capable multi-agent systems that remain entirely predictable and easy to debug. That's your lot for this one. Catch you next time.